Good morning, children. Welcome to your chemistry online class. We know we almost reached to our examination. Today we'll discuss very important topic called gas laws. In the examination point of view, gas laws are very important. We know there are many gas laws. In that, a few gas laws are very important. Today we are going to discuss about every gas laws. So let's start with Boyle's law. So at the examination point of view, you should know the statement or definition of the law and its mathematical symbolizing. How we can mathematically represent a law. So while examination, in the question they may ask state Boyle's law. In such question you have to state the statement or you have to define the law with its mathematical representation. Then only you can score the complete mark. And how we are using this law in our daily life. Such things also you should include in such questions. So we'll see with each law. For example, Boyle's law. We know Boyle's law representing the inverse relationship between pressure and volume. What do we mean by inverse relationship? It means one increases, the other decreases. Inverse relationship. So we'll see, you should know the statement correctly. If you write the statement exactly as the statement, then only you will get full mark. So for example, Boyle's law states that the volume of a sample of a gas changes inversely with the pressure of the gas as long as the temperature and amount of the gas remains constant. So we know here only two factors are changing. If we take a gas, there are certain parameters: pressure, volume, temperature and number of moles. These are the parameters of a gas. So if any two will vary, we can state it as a law. And if we take any law, one thing will be constant. For example, if you take Boyle's law, the temperature remains constant. It's a pressure and volume relationship. Only pressure and volume varying, temperature held constant. So you should know the complete statement of the law. When the pressure of the gas decreases, what will happen? It's inversely proportional. No, so the volume of the gas increases. And opposite, when the pressure of a gas increases, the volume of the gas decreases. And its mathematical representation is proportional to 1 by V. And for doing problem, we are using this equation. P1 V1 is equal to P2 V2. This is the equation we are using to solve the problems. For example, if you take a problem, if you read this problem, you can see that there a hint is given. This temperature is held constant. So if in any problem you have seen that only the temperature is constant, we should know it is based on Boyle's law. So we should use the equation of the Boyle's law. If you see here, you can see this is the volume, its pressure. So only its pressure is changing. We should know the new volume. So we should use the equation of the Boyle's law. Next one is Charles' law. It states that the Kelvin temperature and the volume of a gas are directly related when there is no change in the pressure or amount of gas. That is, it's a temperature and volume relationship. Here pressure held constant. So if the temperature of a gas increases, volume also increases. It's observed by the scientist Jacques Charles. That's why this law named as Charles law. Its mathematical representation is V1 by T1 is equal to V2 by T2. So in sample problems you can see pressure remains constant, then you should know it's Charles law. So you should be careful to do the problem. So use that equation and put the values whichever given, then you will get the answer. Next one is combined gas law. If these two gas laws, that is Boyle's law and Charles law, combined together, we will get combined gas law. Next one is ideal gas law. The law that describes the pressure, volume, temperature and number of moles of a gas. It's represented by the equation PV is equal to nRT. So while writing an equation, you should mention what are the terms are given in the equation. So in the examination, they may ask state ideal gas law. So you should state the law with its equation and you should write what all things are there in the equation. Here P is the pressure of the gas, V is the volume of the gas, N is amount of gas or number of moles of the gas, R is ideal gas constant, T is the temperature of the gas. And one more thing is there, while doing problems in Charles law, you have to convert the degrees Celsius into Kelvin temperature. So at STP, standard temperature and pressure, standard temperature and pressure means standard pressure is 1 atm, 1 atmospheric pressure, and standard temperature is 273 Kelvin. At STP, if you take any gas, it contains 22.4 liter of gas and 1 mole. This is the standard condition. And universal gas constant will be these two. If we are using atmospheric pressure and liter, we should use the value of others. Or if we are using Kelvin and Kelvin Pascal, kilopascal, we should use the equation is this. Next one is Gay-Lussac's law. Gay-Lussac's law is it's a temperature and pressure relationship law. Here temperature and pressure is directly proportional. That is, if temperature increases, the pressure also increases. If pressure increases, the temperature also increases. Its equation is P1 by T1 is equal to P2 by T2. Next one is Avogadros law. It's also very important. It states that equal volume of gas at the same temperature and pressure contain equal numbers of particles. This number is known as Avogadro number, that is 6.022 into 10 to the power 23. 23 atoms or moles. Its equation is this. Next one is Dalton's law of partial pressure. At constant volume and temperature, the total pressure exerted by a mixture of gases is equal to the sum of the partial pressure of the component of gas. For example, if you take air, in the air it contains nitrogen, oxygen, carbon dioxide, etc. So these all are gas. So the pressure exerted by the air is the sum of oxygen plus sum of nitrogen plus sum of carbon dioxide, sum of chlorine, etc. This is this law. Its mathematical representation is P total is equal to P1 plus P2 plus P3, sum of the total of the all pressure of the gases. So such questions also you can expect. For that you should add all this pressure. So this is all about gas laws. It's very important, children. So you should study the statement of each law, the mathematical representation of each law, and what are things in the mathematical representation also you should study, and daily life application of each law. Thank you, children. Don't skip this part. Read well, solve the problems well. Okay. Thank you.